For a series, it doesn't matter what type of series it is, but for a series, it basically means add up a certain number of terms. Maybe I just want you to add up the first 4 terms, and if that's the case, just find the first 4 and add them up. That's not that hard. But if I want the first 100 terms, I don't think you're going to want to find all 100 and then add them up. And so keep that in mind. And if I tell you it's an arithmetic series, that means it's the sum of the terms of an arithmetic sequence. It means that's basically how you had to find it. Remember, yesterday was arithmetic sequence, which meant we basically had to add by something to get from term to term. This is saying now that you know it's arithmetic, then find those terms, add them up. Okay? Now, sometimes you can find the sum. Again, it's S sub n. That n is just notation there of the first n terms. Again, maybe it's 10 terms, or maybe it's 100, who knows, can be given by this formula that I know everyone in here has used before. Not necessarily when doing sequences in series. If you remember the little problem that Gauss solved, the first 100 integers, he took the first one and the last one and added it together, and then we multiplied by 50, which was half the terms. He's the one that came up with this formula. Okay? So again, S is the sub n is the sum, n is how many terms, a sub 1 is the first term, a sub n is whichever term, maybe it's the 10th term, 20th term, whichever one I want you to add. So determine the sum of each described series. So the first 50 positive integers. So the first 50 positive integers. Well, I think we can sum that up. So it's sum of the first 50. That's where I would put. You don't have to put 50 there if it's going to confuse you. Well, do I know how many terms there are? Well, if it's the first 50, there's going to be 50 of them. Over 2. I'm following the formula because it's n over 2. What comes next in the parentheses if you look at your formula? A sub 1. Okay, well, what's the first positive integer then? Is 1. Very good. Now, this one's pretty straightforward. What's the 50th positive integer? Yeah, I'm going to go with 50 on that. Yeah, probably. All right, that'd be the 50th. Now, here is where problems can basically happen. Those might not always be that easy. And we're going to run into that actually on the next problem, that it's maybe not that easy to find that last term there. And now I would suggest probably to follow a little bit of order of operations there. And what do we got here? We got, what, 51? And we're going to take it times. Basically, that's 25, right? And that will be the sum of the first 50 terms. And you go ahead. What do you get? $1,275. Now, there is nothing wrong with writing all 50 of them out and doing 1 plus 2 plus 3 plus 4 plus 5 on your calculator. But realize if you miss one of them or type it in wrong, you're not going to get the right answer. And that is the sum. So notice, did I do anything with that 50 right there? No, it's just notation is all that is. Okay. So I mentioned that letter B might be a little bit more complicated. So now we're going to do the first, we'll say positive, first 10 positive odd integers. Well, how many terms are we going to have? We're going to actually take the sum of how many terms? There's still only going to be 10 of them. Equals, well, it's still 10 over 2 then, because there's going to be 10 terms. Normally the first one, no matter how I give you the problem, normally the first one's probably going to be the easiest of the bunch. And what is the first odd positive integer? Well, 1 again. Now, some people will tell me that the 10th one is 10. Well, and some of you I saw kind of going with the fingers there to figure out what it is. And what some people do is they just write it out. Or they'll go 1, 3, 5, you know, then they keep going. That's one way of doing it. Is it actually 19 if you sit there and do that? I see more fingers going there. It is. Now, how could you have figured that out if it was more complicated? Because let's face it, that's one you could sit there and do by your fingers. Well, if you needed to, you could have referred to that. Will that give you any particular term you want of a sequence from yesterday? If it's arithmetic, that will. And if you want to see if this will work, which term do I really want? I want the 10th term, right? I'm going to show you that this will work if we get a more complicated one. Again, in this particular sequence, then, what's the first term that we're talking about? It's still 1. So 10 minus 1. Now, here's the problem for some people. If you go from one odd integer to the next, what's the difference? Yeah, somebody said it 2. Okay, you go from 1 to 3 to 5, all right? And you do that math. Basically, you take 9 times 2, which is 18, and add 1, and you get that it would be 19. So that's sometimes how you can find that last term if you're not sure what it is. Let's face it, in the first problem here, we knew it was 50. But over there, 19 was a little bit harder. But now that we found that, this problem really isn't that hard at all. We take 5 times 20, and we found out that the sum of those 10 terms is 100. Any questions on that? All right. Well, we definitely don't want to go out to 60 terms. I don't even think you want to do that with your finger, right? We know the first term is 15 and the difference is 80. So by the time we get out to the 60th term, is this going to be kind of big? Again, you're probably not going to want to sit there and do that on your fingers. Well, let's fill in how much we can. We know it's the sum of how many terms are we actually going to have? 60. Again, there's nothing wrong. If you want to write them out, you can. Does that seem like a good choice here? That's a horrible choice on this one. Well, we know it's 60 then over 2. First term is 15 plus, well, what's the quickest way of going and getting that other term? What we just did on the other page. So why don't you take a second and go get that other term? And then try and finish the sum. Well, let's see how you did. Well, I'm going to use up this space over here. I'll just erase it when we get done. So I want to find the 60th term. First term's 15. N is, well, 60 minus 1. Difference is 80. Oof, so this is going to get big. So the 60th term is 15, and then we have to take 59 times 80. And what do you get for that? 4,720. So the 60th term is 4,735. So is that the sum of the first 60 terms? No, by notation, that is just the 60th term because I have just an A there. It's not an S. All right. So what I have to do then is take that number and put it in there to solve. And that's very believable that it would get that big. So then you add those two together. So we got the sum of the first 60. So we got, what, 30 sitting right there. And then in here we got 4,750. And so it should hopefully be no surprise that this answer gets pretty big. What do we got, 142,500? Okay. Any questions? Letter D, you're going to do very much similar to how we did letter B. If you're curious, I'll just give you the answer and we'll move on to another one. The answer for letter D is 225, for those that are curious. I think we will also skip that one. That one's almost too easy. If there's only 6 of them, why wouldn't you just draw them all out and then just add them up? I would not use a formula on that one. But then this one is a little bit more complicated because it's asking for something completely different. It says determine the first 3 terms. It tells me it's arithmetic. It tells me the first term. It tells me a term along the way is 100, and the sum of those is 1,050. So if I have the first term, what's going to be the most helpful thing to get the second term? The distance or the difference, right? That'd be very helpful if I could find D. Well, my suggestion is let's fill in the 2 formulas as far as we can. Whoops. Because that's the one that on the right is the one that has difference in it. So that's really what I want to find is difference. So do I know the sum? Yeah, that's 1,050. Do I know how many terms that is? No, I don't. Well, we can't fill that in. Do I know the first term? Yeah. And do I know what would possibly be considered the last term? Yeah. Well, I can solve for n, but I want to know d, right? That's what we want to know. So let's go fill this one in. We got 100 equals 5 plus, well, we don't know n. Exactly. Let's find n first, then we can go to the other one and find the difference. Okay. So in this one here, there's a lot of options on this one. Has everybody had a chance to write this down? I kind of went through that quick. Had a chance? All right. I think we can all agree that this is 105 sitting right there. And now it really depends on how you want to do that. We have to get n by itself. So this is really divided by 2, so the easiest way to get rid of that, yeah, let's multiply both sides by 2, because that'll cancel. And what is 1,050 basically times 2? Yeah, 2,100 equals basically n times 105. Yep, divide by 105. Is it 20? Yep. So n being 20, is that the solution to the problem? No, that's how many terms we had. So we started with 5, and it took 20 terms before I got out to 100. So would you expect d to be very big if it took 20 terms to get to 100? It's probably not too big. So now what you can do, though, as some of you said, let's put that right in there then. So it's 100 plus 5 plus basically if you put 20 in there, it becomes 19d. And that's up to you, but I always like to get rid of these first. Subtract 5, 95. You might be a little worried at this point, think, wow, d's not going to be a very nice number. It actually works out better than you would think. When you see 95 and 19, you don't think it's going to be that good, but by 19, d is 5. All right, so what's the answer to this question? I got n being 20, I got d being 5. Yeah, basically the first term we know is 5. How do we know that? It's right here. It wants the first 3. So does this 5 count as one of the terms? Yeah, that's the first term. That counts. So really, we were only looking for 2 more terms. And the next term then is what? 10, yeah, because you got to add the difference in. So 10 and then 15. And I think that's believable because then it would be 20, 25. It would take about that long to get to 100. And the sum would be about 1,000 then probably. That's believable in the end. Sometimes you have to use both formulas is really what it boils down to. Any questions?